Jain to all of you. Myself, Professor Dr. Jaishree Jain, Associate Professor in Ajay Kumar Garg Engineering College, Ghaziabad. So today in this lecture, I will tell you about the techniques of virtualization. So this is the part of subject cloud computing KCS 713. So all the final year student can understand what is the meaning of the techniques, what are the different techniques we are used in virtualization. So that is very important, so that we can understand how can we virtualize our resources in before we are going to provide the services over the cloud. We have to virtualize the different hardwares that are associated with our system, so that we can easily deploy the different virtual machines, and when we can easily enhance the resource utilization. So we are going to increase the resource utilization, and for that we have to understand different techniques of virtualization. So firstly we will understand what is virtualization and what are the different techniques of virtualization. So virtualization techniques, we can mainly classify these techniques into three parts. First one is full virtualization using binary translation, and second one is para virtualization using OS assisted virtualization. So the brief main category is the software based virtualization, and second one is the hardware assisted virtualization. So main techniques are, we can virtualize our resources in software based manner, and we can virtualize our resources in hardware directly on the bare hardware. So what is the difference between these two terms? So this is the word software. So what is the meaning of this software? Means when we are going to attach the resources like CPU, like memory, input output devices, which all are associated with our motherboard. So when we are going to deploy one virtual machine, like we have the physical hardware, we have the physical operating system, like we have our personal. So we have two techniques, software virtualization and hardware assisted virtualization. So when actually when we use the resources in our PC, like we have one CPU attached with my PC, I have one RAM which is attached with my motherboard, and I have different input and output devices. So when I am going to use those devices, so I have to install the operating system onto my machine, and then the user can install different software applications over them. But that is only the part of the single operating system. So when we are talking about the cloud, then we have to actually on the cloud computing, for deploying the cloud services, we have to build up the server. So when we are going to deploy only one physical server, so all we know, when we deploy any server, then we have to arrange the resource pool, and all the resources are going to be attached with only that single server. But in case we can say nowadays every business organization is going to take the facility of cloud services. So there are million and trillion users. So how can we say that only by deploying only one server we can handle all the requests? So actually we have to build the different servers. So when we are going to deploy different server, like if I have deployed 800 servers, so those will emit the CO2, and our that will emit the CO2 energy. So our environment will get polluted. So to preserve the energy and make the green environment, we have to do the virtualization. So when we are going to virtualize, when we apply this virtualization techniques, then that server is going to be, we have only one or we can take 40 servers, physical server, and then we can virtualize those servers. So with the help of virtualization, those 40 server will convert it into the different, we can say onto the 100 server. On each physical server we can make 4 or 5 virtual server, then again for second server we can make 5 different virtual servers. So such that from with the only we have virtualization techniques, and only one server will convert it into the 6 or 7 or 8 servers. So those can we can say there are 8 servers. Only with the one physical server we can operate on the 8 servers, that are the virtual servers. So we going to apply these virtualization technique. So we have two techniques, software and hardware assisted virtualization. So in case of software virtualization, two techniques are there, full and para virtualization. So this is full virtualization, actually means all the instruction, all the processor instructions, all the memory instruction. As we all know, when we have different processor instruction like control sensitive instruction, behavior sensitive instructions, and data transfer instructions. So all these kind of what is the work of the processor, those all the instruction that supports the execution environment, those are going to be translated into binary form. So this is this virtualization can be done by using the binary translation of all the instruction of the hardware which are going to support to execute any user application. And second one is para virtualization, or we can say OS assisted virtualization. So para virtualization, we can say that is a partial virtualization, that is not the full virtualization, and in this case we have some APIs. So in para virtualization, only some instruction are going to be run in virtual manner, but the privilege sensitive instruction will going to run into the non-privileged into the VMM machine. So this para virtualization, we can say this is the partial virtualization, and this full virtualization is the fully translated into the binary form, and all kind of hardware we can get into the software form, and all the virtual machines will easily get the resources, and they can different virtual machine can run in isolated manner. If we have 8 virtual machine VM1 to VM8, so those virtual machine can run onto the isolated manner. So this is the in case where it can be used in case of server virtualization, and this is used in case of desktop virtualization. So that depend which kind of service we are going to be use. So when I have to virtualize the server, then I am going to use the full virtualization. Okay, and if we are going to virtualize the if I am going to use the para virtualization, then this technique can be used on the client machine, where client can work on the different virtual instances. So only on the single machine 2 or 3 guest machine can be run, and the user can work parallelly on to the different operating systems. So this can be used into the client machine. So these two techniques can be used as a virtualization technique. And third one is the hardware assisted virtualization. Hardware assisted virtualization means, so this where hardware is going to be directly virtualized. There is no need of host operating system. This hardware, like we have CPU, we have memory, we have network interface card. So these hardware directly associated with the virtual machines. So we can divide. So for this we have a special kind of CPU which can be easily divided into the different virtual machine, and those virtual machine can easily run into the isolated manner. So this is also we can say full virtualization, because all the hardware that is associated with my system is going to be divided, it's going to be provisioned into the different guest machine. So those machine can run into the full virtualized manner, as all the hardware is going to be associated, and those machine can run parallelly with the independent way. So this is also we can say full virtualization, but this is software based and this is hardware based. So further we will learn the structure or architecture of these techniques. So in case of full virtualization, we can say the non-critical instructions run on the hardware directly, while critical instructions are discovered and replaced with tracks into the VMM. So to understand we know that for virtualization we need one kind of hypervisor firstly, or VMM. This is virtual machine monitor. So either we have hypervisor or VMM with the so it is we can say this VMM is nothing, this can be the hardware. We can say VMM is a hardware, or we can say this is a software, or firmware. So this VMM, if we are going to use full virtualization, then we can say as a binary translator, then we can say VMM is nothing, it is a one kind of we can say one chip or one hardware is there, and this VMM is going to translate all the hardware instruction into the binary form. So this is the responsibility of VMM to assign the resources, all the hardware resources to the gas machine, so that the gas machine user can run the application in independent manner. So when this VMM provided the resources to the gas machine, the user can run the critical and non-critical means privileged and non-privileged instruction. Non-critical instruction means non-privileged instructions. Non-privileged instructions. And this critical instruction means privileged instructions. जो privileged instructions means what is the like we have system calls like fork system call is there, malloc, calloc, alloc, memory manage. If we are going to use a memory management system calls, so these are the system calls that are going to be used in case of memory allocation and deallocation, and there is a command free system call. So these all are the system call, but the library of these functions or body of these function is defined into the kernel of the operating system. So when we use single OS, the kernel will manage all kind of system calls, because kernel provide one kind of interface between the user and the system files. So if we are going to talking about the VMM, so this kernel actually replaced with the VMM, and VMM have all the controls of the hardware. So this is a responsibility of VMM to allocate all the resource to that virtual machine, and in case of full virtualization, all kind of privileged and non-privileged instruction will be implemented into the user mode only, because user have gas machine have all kind of resource, so there will no generation of trap or interrupt. If user is going to be call any system call, then that system call will be handled by the VMM, because that library of that function will be defined into the VMM, because all the hardware instruction will be translated into the binary and VMM have all the instruction. So this is the approach. Both the hypervisor and VMM approaches are considered in full virtualization, and means hypervisor means this hypervisor can be a hardware, and VMM means it can be a, both are the same thing, and this can be hardware, software or firmware. So why only critical instruction trapped into the VMM? So this is very good question. Why are only the critical instruction trapped? Because I already told here, critical instructions means those are the privileged instruction, and user don't have the right to execute those instruction directly, because that are the system defined instruction, and the function, the body or the explanation or of that function is defined into the VMM. So only VMM can execute those system calls, those system defined functions. So it will generate the trap. This is because binary translation can incur a large performance overhead, and non-critical instruction do not control hardware or threaten the security of the system, but critical instructions do. So non-critical means user defined functions, user defined statements can execute in user mode directly, but when the user is going to execute any system call, then those system call will be generate a trap into the VMM, and VMM will going to solve that trap with the help of by finding the library, by finding the body of that function, and execute, provide the support to the operating system and execute those instructions. Fine. So we can say in case of full virtualization, all critical non-critical instruction can run into the gas mode directly without generating any trap. So that therefore we can say running non-critical instruction on hardware not only can promote efficiency, but also can ensure the system security, because that is running in isolated manner. So we can say security is going to be preserved. So next is binary translation. So we are going to tell binary translation. So we have to understand what is binary translation. So this approach was implemented by VMware and many other software company. So this is a one example of hypervisor, or we can say we can use Oracle VirtualBox or Microsoft Hyper-V. There are different hypervisors. So those are going to be implemented, and those are going to be translate the code into the binary form. That code is hardware instructions. So as shown in figure, we can say this is a figure where we can find out the control of the privilege instruction and non-privilege instruction. So we can divide the privileges into the form of rings. So we have 4 rings here, and at the bottom we have the hardware associated with, that is the host computer system, means that is the physical server where we have associated all kind of hardware, and at ring 0 we have VMM. So for full virtualization, that VMM is going to install directly onto the hardware. This can be any hardware or firmware or software. So when we going to attach or install this VMM, then we can make the different virtual servers onto the one physical server. So we have here guest operating system. So it can be guest OS 1 or guest OS 2 or guest OS, we can say VM1, VM2, VM3. So we can deploy multiple virtual machines over that physical server, and above that at ring 2 we have the device driver interfaces. This is blank, but we have here the device driver interfaces. So at layer, this is bottom to top, and above on the top we have the user applications. So when user is going to execute one kind of instruction, so we have the user mode, the user defined instruction will run on to the user mode. It is very easy because there will be no generation of trap. But when this user is going to execute the privilege instruction, then the request, this will generate the trap, and request will go to the VMM. So when this is direct execution of user request, because in case of full virtualization, all this hardware is divided and provided to this guest OS. All instruction or libraries are provided to this guest OS. So when user will execute any system call, we have system calls. Privilege instructions means we can access those privilege instruction with the help of by calling the system calls. So this is the main call, that is, we can say fork is a system call, or alloc, malloc, these are all the system calls. So when this call occur, then trap will generate and guest OS, but guest OS will handle all kind of trap. So OS will need not to be modified. All the instruction can easily executed in VM mode only, means in guest OS mode, all instruction, all these privileged instruction can be executed directly. So this is here written, direct execution of user request. So binary translation of OS request. So this VMM have already done the binary translation. So it will provide the library of that system call and can execute that user request directly. So this is a case of, in case of binary translation or full virtualization, we can implement this kind of privilege. Next is an alternative VM architecture for full virtualization. Actually, in case of full virtualization, either we can do the binary translation on directly on the bare hardware, or we can also install the host based virtualization. Means host based virtualization means one physical OS will present onto the host machine. One physical OS is present into the host machine, means we have one physical server equipped with all the hardware, and along with the one operating system that is already installed into that server. So we have at the platform level, we have the physical operating system there. So we can say that this virtualization is called as a host based virtualization. So alternative VM architecture is to install a virtualization layer on the top of host OS. So at the bottom, we can say at the bottom we have the hardware associated with my motherboard or with my system, and above that we have OS. Means we have installed one operating system directly on this physical hardware, and above that we have installed the VMM or hypervisor, and when VMM get installed we can make the different guest OS here, VM1, VM2 up to VMN. So this is a structure in case we are going to use full virtualization, that is host based virtualization. So this is alternative architecture, and but in this architecture what is the advantages? So we can say first, user can install this VM architecture without modifying the host OS. So already all the library or binary translation will also have done here. Binary translation is already have to be done here. So this instruction, this hardware is going to be translated, and all kind of instruction will going to be installed at the VMM. So VMM have all the privileges, and this VMM, this OS will run the instruction of host operating system, and this VMM will run all the instruction of these VM machines. So the virtualization software can rely on the host OS to provide the device driver. So there is one issue, that is what the drivers, I call that ring 2. There are the device driver interface. So this interface, if we are going to be used one host OS, this guest OS will be converted into host OS. If this is host OS, then host OS have it on device driver. So when we have host OS and above them we have the guest operating system. So if the user will implement any system call, will request for any system instruction, then the request will be passed on to the host operating system. So this host operating system provide the device driver and other low level services. This will simplify the VM design and ease of its deployment. So the complexity of full virtualization that is going to be directly on the bare hardware, that can be resolved if we are going to use host based virtualization. So this is better than full virtualization of bare hardware. So host based approach appeals to many host machine configurations compared to the hypervisor or VMM architecture. The performance of host based architecture may also be low, but performance can be degraded if we are going to use the host based full virtualization, because all kind of trap will be handled by the host operating system rather than guest operating system. So performance will get degraded. So advantages of full virtualization is security. Emulation layer isolates VM from host OS to other applications. Security means because all the VM are going to implement it in isolated manner, and this emulation means what we have do the binary. Emulation means binary translation, what we have done. Binary translation, after binary translation, what are the different instruction we got, that is stored into the VMM, and we can say one emulation layer will get installed over the bare hardware. And total VM portability. Total VM portability means because all the packages are combined and allotted to the guest operating system, so we can import that virtual machine data to the another virtual machine easily, because that VM have separate code, separate instruction, and can independently run. So we can say all thus emulating hardware interface and guest OS forms a standard package. So this package gets integrated into the one VM, and this can be imported to the other VM. Run unmodified OS. So this is major advantage, because all the instructions have been assigned to be allocated to the guest operating system. So guest OS need not to be modified if there any privileged instruction occur, then no trap will be generated. So disadvantage is what? Performance degradation in hosted full virtualization. I already told that ki if we are going to use one host operating system, then all kind of trap will be handled by host operating system. Performance will get degraded, and hardware dependency in bare metal full virtualization. If I am going to use bare metal, then hardware dependency is there, because the hardware get emulated and emulation layer have to be properly assigned to the guest operating system. So applications of full virtualization is hosted full virtualization is used for desktop virtualization, when the client on the client side one desktop is there and different guest OS can be installed. So this is installed onto the desktop virtualization, and bare metal virtualization is used for server virtualization. These are the example of Microsoft Virtual PC, Oracle VM VirtualBox. These are the desktop virtualization based technique, and Microsoft Hyper-V and VMware ESX server. These are the bare metal based full virtualization. And last one is the server virtualization is used in the cloud computing. So in cloud data centers, we can say this bare metal full virtualization is going to be used. So this is second technique, that is para virtualization. In para virtualization, I already told, I have bottom layer, we have hardware, then hypervisor get installed onto the bare hardware, but this is the guest OS, but it is called the para virtualized because it have partial instruction that is going to be virtualized. So we have the combination of virtualized and non-virtualized instruction. So virtual instruction will going to be execute in guest mode, and non-virtual instruction will going to be run onto the, will generate the trap and will going to be run onto the VMM or machine mode. We have user mode and machine mode. So this is called as para virtualization. Need to modify the guest operating system, it generate the trap. Modify means trap will get generated and will be handled by the VMM, and para virtualization provide the special API for OS modification in user application. Only virtual instruction will get executed in OS mode, guest OS mode, or non-virtual will be at hypervisor mode. So performance will get degraded. So this is the para virtualization, and this also can be host based OS assisted para virtualization, where we have host operating system on at the top of the hardware, then hypervisor will get installed, and again we have the different guest operating system, but here is written modification. All these get OS will get modified when it will generate any trap for executing the system calls. So we can say in this case hyper calls will be there, because system is what? System call, or we can say hyper calls will generate and hypervisor will handle those trap. And in case of host operating system, the instruction will going to be run in host OS mode, machine mode. So we can say this VMware ESX server will have the host base full virtualization. So this is the architecture of host base VMware ESX server. So we have hardware, we have VM kernel, scheduler, memory management, SCI devices, Ethernet, and VMM is there, and guest OS will run on the above of the VMM. So thank you so much. This is all about the virtualization techniques.